any computer audio, so if you guys are worried about that, I'm not recording any computer audio. So if you unmute and talk, you will not be part of the video. So in case our one student who's not here does decide to watch this video, this is all that you've missed. We started talking about what our notes are going to be about today and wrote that down, and we watched the quadratic equation video. So guys, one thing that we're going to do before we dive into quadratic formula is talk about the other methods that we've been doing, one of which was that whole solving with strategies, or I forget exactly what they called this. But go ahead and jot this down real quick. 2x plus 3 quantity squared. You don't need to see me writing it down because your writing's probably nicer than mine. Minus 4 times the quantity of 2x plus 3 minus a constant of 12 equals 0. Now, we got to try to figure out how to solve this, but we should probably be strategic about it, is what we kind of kept being encouraged to, like, solve with strategies, right? Or structure, I think they called it, but at a certain point we just kind of call it strategies. What was the general idea? Because, guys, a couple of us still have a low score in this activity. What was the general idea of solving with structure? Can anyone kind of like sum it up for us when we look at a problem like this? Yeah?
Substituting in a variable to make it easier to do in the long run.
Yeah, make it easier. So this whole idea is like temporarily, right? Temporarily, I'm going to go ahead and show my screen now. Temporarily make it easier. So temporarily make easier. And we're going to do that by identifying something that we could replace. So we have 2x plus 3 throughout this thing many times. What did we in Khan Academy use to replace it with? P. Salcon likes P for some reason, like as a variable. I think because it doesn't look like really any other number. It's hard to confuse that with anything else. So let's go ahead and rewrite this, replacing that with P. And guys, this is a problem that 6 out of the 9 of us messed up when we tried to do it. So that's why I figured we should probably go through it. So P squared minus 4P minus 12 equals 0. That looks a lot simpler, right? Immediately, that just feels better. So now when I think about factoring this trinomial, so I got to pay attention to what you... Guys, if I'm writing and you can't see me, just tell me real quick, like, hey, move your paper. So there's no leading coefficient except for 1, right? So when I say there's no leading coefficient, I really shouldn't say that. So there's a leading coefficient of 1. I'm thinking it might factor like this easy enough. How do we, again, determine the constants involved in the binomial? I think I need to make my camera go up a scotch. Stay. Nobody touch it. So to figure out these constants, right, we have to make a product of negative 12 and a sum of negative 4. If we want to think back to like 7th grade, you guys might like revolt when I do this, but we can always do this, right? Product of negative 12 and a sum of negative 4. Katie Ann?
I think, like, how I did it is, I did P minus 4 times P.
Okay, keep going because I'm curious.
And that would equal 12 if you bring the negative 12 over. And then I found out that...
Wait, P minus 4 times... Or do you mean P squared minus 4P?
No. I think she means it in parentheses. So like P minus 4 times P,
yeah,
which equals 12. And then I found out that that is 6. And then, so that simplifies out to P equals 6. And then you add that in, so X equals 1.5. I think.
For add a 0?
So, like,
So if I follow what you said bring the 12 over.
Yeah.
then we'd have p squared minus 4p. So factor out a p, right? But now we've actually got to equal 12 instead of equaling 0.
And so if you make it 6, it's 6 times 2 is, wait, 6 minus 4 is 2, and then 6 times 2 is 12.
So wait, you said if I make p 6,
Yeah.
then p is 6.
Yeah, equals 6. And
Yeah,
then,
you said 1.5.
I know, x equals 1.5.
Oh, okay. Well, okay. You took a pivot really quickly. So what Katie Ann figured out, I just tried to scroll my paper. Oh my gosh. Literally, I was like, go up, go scroll. Like I reached over and grabbed my mouse. Guys, I was up until like 1 in the morning grouting a shower. So I'll show you a picture at the end of class if you want to see. It's looking good, but God, it was like torture, right? I started at 8 o'clock and I'm like, we'll get this done in a couple hours. No, we didn't. So Katie Ann said P is 6. I agree, but there's another option. P's not just 6. Katie Ann essentially played with this and said, what could P equal? If I come back up here to the binomials, I can think of two numbers that produce negative 12 and sum to negative 4. I'm going to cheat a little bit and use the fact that you already told us 6 is an option. So if 6 is an option, negative 6 would need to be one of my constants, right? And then the other constant would have to be positive 2. And we plug that in, 2 times 2 minus 4. Wait. Is P 2? Ah, P is negative 2. So although we plugged in a positive 2 up here, the other P option is negative 2. Because remember, it's the opposite of the constant that we plug in. So be careful. Don't think about positive 2. If I come down here and try to plug in, it'd be negative 2. And that'll work. Negative 2 times negative 2 minus 4. This will be negative 6. Negative 6 times negative 2. Positive 12. Sorry if I talked a little fast there. I've had a decent amount of coffee because, well, I was up till 1 in the morning. Questions on how we got our P values. We just factored this kind of simpler, still not really simple, but we factored the simpler trinomial. From there, what do we do? Oh, yeah.
So P is equal to 2x plus 3, so you would put the value of P is equal to 2x plus 3 and then solve for x.
So since we know P is equal to 2x plus 3, then we can actually, I like doing this, guys. A lot of math teachers well, I don't know about a lot. Some math teachers will tell you have to write a new step and replace the P with one of your numbers. You can just keep going with the equals, right? P is 2x plus 3. Another thing 2x plus 3 equals is 6. Another thing 2x plus 3 equals is negative 2. And we solve these both algebraically. So if we subtract 3 from both sides, we get 12x equals 12. Just bear with me today, guys. Actually, this whole week, probably. I'm trying to finish this bathroom before my wife leaves on a trip this weekend.
Negative 2.5 or 1.5.
Ooh, yeah, this. So I like working in rational values. So 3 halves, right? There's your 1.5. And if I subtract 3 here, this would be negative 5 equals 2x. And then x equals negative 5 halves. There's your other value that you just gave me. So 1.5 and negative 2.5. Questions on how we took what looked to be an insanely complicated equation and made it, in my opinion, a lot easier. And for the record, quadratic formula wouldn't do you any good here. It's way too complicated. Now, if we did the multiplication if we did the foiling of this, yeah, you can go to the bathroom, man. Okay, you guys may not be used to this because I don't know how 8th grade teachers work or how last year it's like 7th grade teachers work. In my room, I don't care. If you have to go to the bathroom, you have to go to the bathroom. What matters is, do you want to miss what we're doing? So if you're comfortable with missing this, go. But if you're like, I don't know how to do this math, but I'm uncomfortable, so I'm going to go to the bathroom, don't do that, right? So I'm going to trust you guys not to leave when you should be watching. We're going to do another one of these. So if you're comfortable with this stuff, go to the bathroom. Or if you just have to go, that always trumps, right? So that's always, that's, Who? 8th grade teachers? Whatever. I'm not really an 8th grade teacher. Yeah. I'm leaving. I'm leaving. Amar. Oh, you're eating. Never mind. Sorry, I just saw it. Man, all right, let's do another one of these crazy complicated problems. No? Come on, you got to be excited. All right. Sorry, my views are different on my two screens, so there's nothing in front of the 7x plus 2 squared. We might just do one more of these if you guys feel good after this one. Like, this one might be it. I'm going to change colors just to change colors. Because why not? Now, another word that you might like just want to start working into your math vocabulary is allow. Yeah. Well, that was really fast. Great. I think you're a little quicker than us. Or did you already do this in Khan Academy at one point? Well, good for you. I mean, it's working, though. I don't want to whisper and them not be able to hear me and be like, what are they saying? So if we allow p to equal 7x plus 2, or allow 7x plus 2 to equal p, I'm strategically only showing you guys so much of my paper. I can see what you can see, I think. What, the green? Or the, oh! Guys, you should know how to work. Well, I don't know. You had missed the hall last year. You should know how to work this. Just somebody run up and hit this. Well, how long are you guys going to let me keep teaching with that bar there?
Well, we're asking you to move it up, and that just got rid of it because you're only showing.
Well, I know, because I only want the people on Zoom to be able to see so much. All right, keep moving forward on your own. A couple of us still have like a 25% on this homework. So that is why I'm doing this, is I know a couple... Wow, crap. Should we do something with that 27? No? I want to. I did something with the 27. So I went ahead and moved the 27 over to make this quadratic. Remember, quadratic means equal to 0. Then we're thinking sum to 6 produce negative 27. There's only so many things that make negative 27, but I have a leading coefficient of 1. Wait, Katie, you told... Oh, you keep solving for x when we're trying to solve for p. Well, there's got to be 2 p values. Wow, sassafras. Now, wait a minute. Okay, so if our positive wins, then the positive needs to be bigger and the negative needs to be smaller. But if you said 9, then 3 would work. And again, I'm working in Sharpie, so I can cross things out if I need to. But you said 9. I'm thinking 9 times what makes 27. But my 9 in the factored form needs to be positive to get the 6p. So when we do the outside and the inside, bum bum bum. Ah, maybe it's because we worked so fast. We're not in a race, Katie Ann. It's a marathon. So P is -9 or P is +3. Now, as we take our time and, and we substitute P back in, we can say 7x plus 2 equals that -9, or the 7x plus 2 equals +3. I can subtract 2 over here. We get 7x. I want to play tricks on you guys, but I'll just go ahead and write the right number. 7x equals -11. And over here, 7x, if I subtract 2 over here, 7x equals 1. 1/7, which is not very fun. If we want to remember the cool decimal fun, yeah, the sevenths. 14, 28, 57, or 142,857. So 14 doubled is 28. 28 doubled would be 56, but it actually goes up to 57. But this is kind of irrelevant. X equals -11/7 or 1/7. All right, so that is our solving with structure review to make sure we all understand what is going on. The first thing we do is substitute or allow a replacement of a binomial by a single variable. Because anytime we can make math easier, we want to. So then we solve the quote-unquote easier trinomial, factor it out, and then we use that factored solution to then get the actual solution to the original, subbing back in our p-value. Boom. Now, that's great. Until... maybe I'll use green. Red is a little intense. Until... what if our leading coefficient isn't 1? Or what if, no matter what we try, the constants in the binomials just don't work out? Alina? You gotta sing it. Well, then... we gotta use what formula, class? Here, let's sing it. Let's sing it together. All right, so x equals what? Plus or minus the square root of b squared minus 4ac over 2a. Guys, as a formula that you're asked to memorize that is way too complicated, I know that like YouTube videos kind of cheesy, but songs help you memorize things. So you might be on an SAT someday, and like seriously, you might be taking the SAT and you're sitting there like, and I just want you to like think back to me and in your head thank me for showing you that awesome YouTube video. That's fine. Hey man, if cheesy helps, what's that, Aaron? Well, I know, but like in your head, right? You know, send me some good vibes. Send me some good vibes. All right, so situations like this, right? And we can solve more of these structure problems if you guys want. I just figured I can take those questions by request. Hey, Amar, we're having our 7th graders go blow their nose out in the hallway. So if you want to hop up there, there's a bunch of Kleenexes out there. Yeah, I should move these actually. Especially because the trash can's there. It is misleading. So on the podium out there where you guys used to sign out, since we're not signing out to the bathroom. Yeah, there should be a bunch of Kleenexes in the hallway. All right, so 3x, wait, what? 3x minus 9x squared plus 10 equals, this is broken. Why is this quote unquote broken? Well, it's not really like broken, but I mean, yeah, just go ahead. Yeah, like we order our variables by power, right? And literally, it's called the order. When somebody asks you what's the order of that value, they're talking about what power does it have. So we got to fix this and make it negative 9x squared plus a 3x plus a 10. I don't have any paper under here. I am writing on my desk. Well, I guess Sharpie definitely bleeds through. I don't want to, well, that is wrong. I made a really bad boo-boo yesterday in Math 7 and tried to take a shortcut and it didn't work, but I didn't realize that we crashed until after. I can't do that though, because you guys can halfway see through it, and I'm sure you're like, what was the mistake? I should have multiplied by a reciprocal of a value, and instead I tried to multiply by the value. So now we identify our A, our B, our C, right? Which we've talked for most of our time here, that this, sorry, we're not making fractions, is our A value. This is our B value, and our constant is our C value. So the coefficient of our x squared is our A. The coefficient of our x is our B, and the constant, there's a co in that word, the constant is the C. So now we just plug in, right? So we're going to set up, I'm going to use another new color here. So x equals the opposite of our B. Some people like to do negative and then parentheses, because if you build this in your calculator, the easiest thing to do is do negative and then an open parentheses and a closed parentheses. Plus or minus, if we're writing this out, we can just write these things, but we will probably want to split these. B squared, my first time through, I like to write the number that is getting squared to make sure I don't goof up. Minus 4 times A is negative 9. Times C is 10. Now this is when, even with a calculator, this gets dangerous. Because this needs to be minus, and this needs to be negative because that value was like actually negative. If we put a minus in here, it breaks what we're typing. So like literally, if you put a minus in the wrong place of your calculator, it breaks it. And then over 2a, over 2 times, again, we need the specific negative. So, well, let's for a moment solve this on paper before we get to calculators. This plus or minus splits us into two options. So I'm going to actually start to color code now. I'm going to do a green option and a red option. Green's going to be my plus option. So we know this is x equals, so I'm just going to start writing. We have negative 3 plus, remember this is my plus option, square root of, I'm going to start to simplify things. 3 squared is 9. Okay, so negative 9 times 10. I'm going to go ahead and just keep some of this left to solve. I'm not going to skip too many steps. Everyone should be doing this with me, please. Over negative 18. Any questions up to this point? I don't want to move too far ahead without stopping for questions. Well, what's minus a negative gonna be? I'm gonna go ahead and write it here since I already wrote the minus. 4 times 9 is 36, so 360. Yeah, this is gonna become plus. So this is really negative 3. Thank you. Wow, I made that square root way too big. And we get negative 3 plus the square root of 369 over negative 18. Now, does this We're not out. Oh, yeah, it's gym. The weird break between gym and 7th grade is in between our class. Does this plus or minus option, when we go to make the option that uses the minus, does it change any of the math that we've done? No. The only thing it changes is that, right? Because a positive square root has two solutions, either the positive solution or the negative solution. So now that we've found this, we can actually say, well, the other option is just -3 minus square root of 369 over -18. We don't need to do all the math over again. We already did it. Now, this value inside of the radical, anyone know what that's called yet? Ooh, it's got its own vocab word. What's it start with? Yep. D-I-S. C-R-I-M. It is the discriminant. So if we just want to make a let's learn vocab, now I'm going to have to remember how to spell discriminant. D-I-S-C-R-I, discriminant. I think, give me 2 seconds and I can find out. D-I-S-C-R-I-M-I-N-A. Dang it, this is an A. N-A-N-T. Sorry, I didn't say I was sure about my spelling. That's like the last thing you're going to hear me say. Now, we'll talk about what the discriminant is. Not now. We'll come back to that. That was very anticlimactic, right? We'll talk about it, not now. So, well, we could have done all of this in our calculator, but what fun is that? I am so glad I have you, rays of sunshine. You just make my life just so beautiful. Now, the new 84 calculators are slightly smarter, but I want to show you guys an example of if I was trying to type that into my calculator, right? I would type negative parenthesis 3 parenthesis. So if you have a TI whatever, I would get it out and start trying this with me. Square root 3 squared. There's a reason I'm going to type all this like this. -4 parentheses, -9 parentheses, parentheses, 10 parentheses. Now, crap. I want all of what I just typed to be divided by 2 times a. What do I need to do to make that happen? Now notice, this is a negative. If I make that a minus, it will break things. Unless the new smarter calculators just fix it for us. What do I need to do to make everything I just typed divide by the same thing? We need to group it. We need to add parentheses to it. So in front, and guys, this is a feature it took me too long to start using. Second insert will bump everything else to the side. And what I really like about the TI-84 is the parentheses change sizes. So I can see my bigger parentheses are grouping the numerator. Then I can divide by, and I'm going to group the denominator, 2 times my a. So notice that my denominator will need parentheses for the -9 and parentheses for the 2. There's a reason I've typed this all out in this complicated, I've typed out more than what we, simplified out on our paper. If we hit enter, this is going to be the green solution. Now, that's not very nice. So, really, what we often do is leave it in reduced radical form. So this is a gross answer. Another way that I could try to clean it up a little bit is, well, is there a square root to 369? That's really my question. No, not a nice one. Is there a way to simplify 369 into a perfect square and another number, like multiply? Like, can I factor 369 into... Trying to find what I'm trying to find. Anyone have an idea? I'm really just trying to use wait time. Guys, what does this number end in? The number under our radical. It ends in a 9. Should we try and see if it divides by 9? Because 9's a perfect square, right? So 369 divided by 9, hey-yo! So if we want to clean this up a scotch, which is what I'm going to write in blue, is this is the same as -3 plus radical 9 times 41 over -18. Remember, I might run out of space. We can clean this up by factoring out or like kind of reducing out any perfect square that we can take. So this becomes -3 plus 3 radical 41 all over -18. This, dang. I was close. I could go up. Yeah, we could go up. Let's go up. Well, here's what I'm going to do. We're going to go equals. Literally, we're just going to start again. Yes, give me a second. I can only do so much at once. I am only human. Shh, don't tell my secret. Okay, this part is where people like try to mess up. Yes. Here's the thing, and guys, like, even if you've been thinking, oh, I know it, it's just the quadratic formula that he's showing us. It's the reducing part. This plus in the numerator, or even if it's a plus minus. So let's merge my red and my green back together. Let's say, because we're just trying to simplify it, I can add the or minus, and really I've now merged my red and green back together. I'm going to come down here and do that actually. So down here, I'm going to go ahead and put those plus minuses, and we're going to say blue is red and green together. How many terms are in the numerator? Remember, addition and subtraction split terms. There are 2. Right? There are 2 terms in that numerator. So when we go to divide by -18, the radical 41 is part of the term that is 3 radical 41. So what people try to goof up is they try to reduce -3 by -18, this 3 by -18, and somehow the radical 41, that is not correct. Look at how many terms we have, and that's how many reductions, or like if we're trying to simplify, like reduce to simplify, that's what we do. So -3 divided by -18, they share a common factor, right? 3 and 18 can both divide by 3, and so can this 3. So if what we do is essentially divide everything by 3, what we're really doing here, find my sharper. If I divide by 3 on top and divide by 3 on bottom, does that change anything? You know it. You love it. It's the giant one. Dividing by 1 or multiplying by 1 does nothing, right? It just changes numbers. So if we want to reduce this, we see that 3 and 18 share common factors of 3. So reduce by 3. That'll become negative 1 plus or minus 1. The radical 41, nothing happens with. All over, well, what is negative 18 divided by 3? Negative 6. And technically, I don't need to write 1 times a radical. That's like saying 1 Mr. Estes. I don't say that. I just say Mr. Estes. So what I really have is negative 1 plus or minus the square root of 41 over negative 6. So guys, quadratic formula does not mean, I wrote through that negative 6. Quadratic formula does not mean your calculator is going to solve everything for you. Now, if they asked you what's the decimal value of your solutions, yeah, we would use the calculator. But this is our reduced radical form. So you might want to write that note. This is reduced radical. So if they ask for a reduced radical form, that probably means the number under the square root is bad. It's not a perfect square. But is there a square root to 41? Yeah, it's not nice, but there is a square root. So by me asking the question, is there a square root to 41? Brings up the curiosity. What about situations where there isn't a square root? Like not it's just bad, like not that it's just messy, but literally there isn't. What situations don't have a square root? I mean, either you both. Yeah, negative numbers. Ooh. I don't know. What do you think, Mr. Estes? Is that where I comes in? Yeah. That's what Alina just asked. What is an imaginary number, Mr. Estes? The number you make up when you don't have any number friends? The best answer is it's not imaginary. That's what they named it, but it's not a real number, but it exists. So that's my really my big soapbox about imaginary numbers. Now we're not there yet, Alina, but I'll take like 5 seconds to complain. Imaginary was a really bad name. It makes people think they don't exist. Imaginary numbers exist. It's just a different type of number. So before we move on, are there any questions on this process of applying the quadratic to solve a quadratic formula or quadratic equation? Sorry, applying the formula to solve an equation that we can't figure out any other way to solve. We're getting into the nitty-gritty, Mr. Estes.
I remember in college, in the physics class, we were talking about electromagnetic flux and like electromagnetic fields moving. And there's one, I can't remember the problem. There's one problem you had to assume negative area, and it just made no sense to me because my brain could not get off of that. Like that's impossible.
Yeah.
Don't worry about that. Just keep working the problem. I was like, wait, you said assume a negative area.
Yeah, right.
That makes no sense.
It's
so
like
there's all those weird things in there.
in the dark dimension.
Yeah.
I like it.
Makes sense.
Ooh, parallel universes. I know. It's fine though. When she's already done the activities, it's especially when I can like throw something to her really quick and she can answer, it's okay. Or maybe Alina just needs a challenge. Like, I don't know, this? Well, I don't know. Which one do I like? Which one do you guys like? This one? This one? Maybe at the end of class. This one's the same as this one that we just solved. They just gave it to you in a more complicated format. So you guys want to solve this one or this one? This one looks tougher. Let's do this one. Rise to the challenge. You may have already solved this one. Of the 4 people that have done this activity, though, 25% of them got it wrong. So that's still not an acceptable amount, right? We don't want that. We want us knowing what we're doing. Took me approximately 10 minutes to lose my marker. Anyone got suggestions for what we do first? Alina? Yeah, I agree, but there's something we kind of got to do first. Yeah,
You have to add negative 6x squared.
we have to decide what side we want our stuff on, right? So Alina is saying we got to move our 6x, and I don't disagree, but we do have another option. Our other option, if we wanted to make our x squared value positive, is move everything else over onto this side. So we all as a group need to agree what we do. And here's why, Alina. The question is, do we want our x squared, the coefficient of that, to be positive? Or do we want the coefficient of that to be negative? It won't really change what happens. It just changes the numbers that we work with. But since it is easier to move one value than it is to move 3, if we add 6x or 6x squared to both sides, that's fine. Then as I rewrite this, we'll put it in order. So we do have a negative leading coefficient then. So negative 3x squared plus 4x plus 10 then would be equal to 0. Any questions on what we just did? So then, okay, good, it's still recording. So then, start working it. We got our A, our B, our C. Now, I like to write out the formula just as a reminder, or have it like on a note card somewhere or whatever so I can double check. So, guys, it's the signs. The signs are what catch most people. Also, trying to do the math instead of just plugging things in first and then coming back and doing the math. Trying to do the math while you plug things in is another huge trap door. We can go ahead and do all this math, I guess. 12 times 10, 120, so a negative 120. You guys are totally good. If you want to talk to each other about the problem, that is fine by me. And stop me if I make a mistake, like for sure. So I think we're still lucky here. We still get a positive square root. 136. It's not like, great. And 136. Not a perfect square, right? 121 is a perfect square. 144 is a perfect square. Darn. Is there another perfect square we could divide by? So we could divide by 1's a perfect square, but that's pointless. 4? Oh yeah, 36. That might indicate division by 4. And 100 is divisible by 4. So this, I'm just going to make a little note off to the side to save us some work. Square root of 136, we're going to turn into square root of 4 times, okay, so 25 plus 9 more, right? Because 25 is 100, like 4 times 25 is 100. Then 4 times 9 gets you the 36. So 25 plus 9 is 34. I mean, of course, we could use calculators. And then that becomes 2 radical 34. By the way, guys, if you're forgetting why this happens, it's because this becomes square root of 4 times square root of 34. Values multiplied or divided under a square root can be split and square rooted separately. So then we square root 4. And this is where the plus or minus really comes from. That leads us to that plus or minus in the quadratic. So we're going to replace this with 2 radical 34. So negative 4 plus or minus 2 radical 34. How long are we in for? 30. Oh, we're over time. I knew I felt like I'd had you guys for a while. I'm sorry, dudes. Please tell your 8th grade teachers I kept you too long. My bad. I'll wipe your desks. Actually, I'll call custodial and have them spray them down. Huh? I know, I'm sorry. But, like, I don't want to take your lunchtime. Hey, so another day, remind me, and I will let you guys out early if you'd like. That is something that we can do. Oh, yeah, I forgot. That's a thing that doesn't work anymore. So yeah, I should have dismissed you guys 3 minutes ago, so my bad. Always, if you're watching the clock more so than I am, feel free to say like, hey, it's time, or hey, we're close. But that is the end of this one. That is how we would solve that with the quadratic. It's still not nice, so we leave it there. Bye, guys. Have a great day. See you, Zoom peeps. Aaron and Calvin, thank you guys for coming. Much appreciated. Bye.